Hi everyone. In the previous video, we have explained about the conditional branch instructions, unconditional branch instructions, conditional branch instructions, unconditional branch instructions, and the repetitive instructions. Okay, so in this video, I'm going to explain about the call and return instructions. Call and return instructions. Call and return instructions. Okay, so these instructions are used when the microprocessor executes the subprogram. Okay, so when the microprocessor executes the subprogram, or it is also called as the subprogram, or it is also called as the subroutine. It is also called as the subroutine. So then these call and return instructions are used. These instructions are used. These instructions are used. Okay. So first of all, what is meant by the subprogram or subroutine? That means, see here, for example, I want to write a program, the sum of factorials. For example, sum of factorials. Sum of factorials means, for example, 7 factorial plus 5 factorial plus 6 factorial plus 4 factorial. Then what does it mean? Here, 7 factorial. That means 7 into 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 factorial. 5 factorial means 5 into 4 into 5 into 4 into 3 into 2 into 1 plus 6 factorial. 6 into 5 into 4 into. So likewise, so this is an operation. Okay. Plus 4 factorial. 4 into 3 into 2 into 1. That here, what is the repetitive operation? Uh, repetitive operation is here the multiplication, calculating the factorial is one operation, and after calculation of each factorial, the addition is another operation. Okay, so that's why this type of repetitive operations we are using the subprograms. We are using the subprograms. So that means here, for example, this is the program. Okay, and here I'm using the call instruction, and this is the label. Okay, this is the label, and these are all the next instructions. This is the next instruction, and this is a main program. It is called as the main program. Now subprogram. Subprogram is to calculate all the factorials. Here in the subprogram, you are using the instruction. In the main program, you are using the call instruction, and in the subprogram, you are using the return instruction. Okay, so this is the label one, for example. So label one is nothing but the starting address of the subprogram. The starting address of the subprogram. Okay, so this is the one structure, main program, and in the main program, call instruction is used, and in the call instruction, the syntax is the call instruction along with the label one. That means starting address of the subprogram. Here, the subprogram, which is started with this label one, and these are all the instructions, and final instruction of the subprogram is return instruction. So then how the microprocessor executes? Initially, the microprocessor executes the instructions sequentially up to here, and now the call instruction. When the call instruction is executed, when the call instruction is executed, by the time in 8086 microprocessor, the instruction pointer, which is used to point out the locations of the memory location, So when the microprocessor executes the call instruction, the instruction pointer uh, shows the address of the next instruction of the call instruction. Okay, the instruction pointer register, the instruction pointer register shows the instruction pointer register shows the address of address of next instruction of next instruction of next instruction of call instruction, next instruction of call instruction. That is the instruction point. Okay, so now when the call instruction is executed, when the call instruction is executed, then what happens? The CS and IP code segment register and instruction pointer register contents are stored into the stored into the stack pointer. Okay, stored into the stack pointer, stored into the stack pointer, that means stack segment. Okay, so that means here this address, this address is available in the CS versus IP. So CS IP, so this is the address of the next instruction of call instruction that is stored into the stack pointer. Now this CS and IP are loaded, newly loaded with the newly loaded with the label 1 address, label 1 address, that is starting address of, that is starting address of subprogram, that is starting address of subprogram. Okay, so when the CSIP are point out the starting address of the subprogram, then microprocessor execution jumps from main program to subprogram, and here the subprogram instructions are sequentially executed, sequentially executed. Here actually for this example, we can write the subprogram as to calculate the to calculate the to calculate the factorial number, to calculate the factorial number. Okay, and here we are writing the main program as addition of factorials, addition of factorials. Likewise we can write the program. Okay, so when the CSIP are loaded with the label 1 address, that is starting address of the subprogram, then microprocessor executes the instructions sequentially. So then the return instruction is executed. The last instruction of the subprogram is return instruction. So this return instruction is executed. When the return instruction is executed, then what happens? The microprocessor retrieves the CS and IP contents which are earlierly stored into the stack pointer, that is through the push operation. So now the through it retrieves back from the stack pointer. Now again the CS and IP are loaded with the previous address, loaded with the previous address. Okay, loaded with the previous address. Then what happens? The microprocessor, what is the previous address? Previous address means the next instruction, the address of the next instruction of the call instruction. The address of the next instruction of the call instruction. Okay, so now the CS and the IP are loaded with the previous address, then microprocessor again it executes the remaining instructions in the main program, and final instruction is halt. This is the structure of the call and return instructions. Okay, so once again I am telling you, call and return instructions. These instructions are used when the microprocessor executes a subprogram or subroutine. What is meant by a subprogram or subroutine? That means it is a secondary program. Okay, that means suppose for example here, if you are writing a program to calculate the sum of factorials, 7 factorial plus 5 factorial plus 6 factorial plus 4 factorial, here we need to repeatedly calculate the factorial of a given number and the addition. We need to add the addition. We need to add the factorial to the previous factorial number. Okay, so that is the operation. So here the addition is one type of repeated operation, and calculating the factorial is one type of repeated operation. So that's why here in this case we can use the subprogram. Okay, so the structure is the main program. These are the some set of instructions. Here in the main program, the call instruction is used with a syntax is this is the label one and the remaining instructions. And subprogram, this is the subprogram. And subprogram, the starting address is nothing but label one. The starting address is mentioned in the call instruction. Okay, so then the last instruction of the subprogram is return instruction. So here what happens when the microprocessor executes the instructions sequentially and it executes the call instruction. When while it is executing the call instruction, the CS and IP shows the CS and IP shows the next instruction fetching address. Okay, so when the call instruction is executed, this address is stored into the stack pointer. It is stored into the stack pointer, and CS and IP are newly added with the starting address of the subprogram. Okay, CS and IP are loaded with the address of the starting address of the subprogram. Okay, so now after executing the subprogram, the last instruction is return instruction, and when the return instruction is executed, when the return is when the return instruction is executed, then automatically the CS and IP are loaded with the previously stored addresses from the stack pointer. Now the microprocessor executes the remaining instructions of the main program. Okay, so this is the a syntaxes of call and return, and it is used in the subprograms. Okay, I hope you understand. Thank you.